Good afternoon. In today's video, we're going to be taking a look at how we can take the negation of a conditional statement. Now, I think before we jump in, it's important to remember that when we take the negation of a statement in general, when statement P is true, its negation has to be false. So a negation will take any true statement and make it false, but also vice versa. Anytime we have a false statement, the negation will have to make it true. And so this is something that will still hold even when we apply it to conditional statements. Now, I think it's important to remember as well that a conditional statement is denoted P, then Q. We're essentially stating if P, then Q. It's an implication. And maybe even more specifically than that, we can understand P implies Q, or P then Q, or the conditional here, with its truth table. And so let's take a look at this truth table, specifically the second column. A conditional statement is defined so that when P is true and Q is true, P then Q is true. When P is true and Q is false, P then Q is false. And when P is false, no matter what Q is, true or false, P then Q is true. Right, so if we look at these four cases, P then Q, this conditional here, is true, false, true, true. And so when we're negating this, we have to take any of these true rows and turn them into false. So if we look at our third column here for the negation, since the conditional is true in our first case, its negation is going to have to be false. Since the conditional is false in our second case, the negation is going to have to be true, right? And so on and so forth. These last two, since they are true for the conditional, will have to be false for our negation. Now, we should take a note of specifically the one instance, the one case where P implies Q is false. And that's the second one where P, the antecedent, is true and Q, the consequent, is false. And so we have P, but we don't have Q. And that's going to be an important thing to keep in mind when we take a look at specifically what the negation is. And now it's certainly not immediately obvious how we would form this negation, how we would form false, true, false, false on a truth table with a different statement. But if we compare this to the statement P and not Q, I think what we'll find is that these two are actually very similar. Okay, and so let's build out the truth table for P and not Q as well. First of all, we have not Q that we'll need, and that of course is the negation of column Q. And so when Q is true, not Q will be false, and when Q is false, not Q will be true. And so we have false, true, false, true. And then we need to take P and not Q for our third column here. And statements are true whenever both of the two are true. And so for this first one, for instance, in case one, we've got true and false. That's not both, so this will be false. But in this second case, we do have P and not Q both true. And so the and statement, the compound statement, is true. False, false, those are the same, right? These match now, but specifically when we're talking about and statements, we need both to be true. And so this would also be false. And then false, true gives us false. And so what you'll notice here is that our column for the negation of P then Q is the same as the negation, is the same as the statement P and not Q. Again, it's not immediately obvious that this might be the case, but it sort of makes sense when you think about it, because the one case here where P then Q, our conditional, is false is when we have P, right? When we have P, but we don't have Q. So that's kind of like P and not Q. And so then what we can say in general is that for a conditional statement, P then Q, its negation is P and not Q. Or in other words, the negation of the statement P then Q is the same as or is equal to P and not Q. And so we can consider an example now, rather than just in symbolic logic, we can consider an example in English and say something like, if our statement is, if the sun comes out, then the sky is blue, its negation would be P and not Q. So P in this case is the sun comes out. Q in this case would be the sky is blue. So rather than an if-then here, to negate this, we would say that the sun comes out and, right, because this is now switched to an and statement. The sun comes out and the sky is not blue, because we're taking the negation of Q. Right, and when you think about that like this, that would be the condition that would make this wrong. Right, and that's a lot of the times the way I like to think about taking a negation is, if we read that statement, if the sun comes out, then the sky is blue, well, what would have to be true in order to contradict that, in order to say that that was incorrect? Well, what would have to be true is that the sun would have to be out and the sky would have to not be blue. And both of those things would have to be true in order to prove wrong our original conditional. And so that sort of hopefully gives a little bit of an intuition as to why this is the negation. Where I think this gets really interesting, however, is when we put together a few different logical statements and say maybe something like P and Q implies R. And if we wanted to take the negation of this entire thing, right, so let's say find the negation or write the negation. This tends to feel a little bit trickier, but we want to keep that same principle in mind, that the negation of the statement P implies Q, right? So the negation of any conditional is going to be P and not Q. Now we have something a little bit different than P and Q here. So we've got to determine in our specific example what is playing the role of P and what is playing the role of Q. Right? And these are based around the if-then piece, the arrow. And so P, which is the piece that comes before the arrow, is called the antecedent. Well, notice that that stays the same. We don't touch that at all when we take the negation. And Q, which is known as the consequent of a conditional statement, does change, and we negate it. So our goal here is to identify, based on what is surrounding this arrow in the conditional we have written, what's the antecedent and what's the consequent. And then we'll put an and between them in the end. Right, and so if we take a look here, the thing that is functioning like P does in our regular conditional is this entire thing in parentheses, this entire statement here, which is P and Q. Right? So that sort of functions like P does in our standard example or in our definition. And so we can take that piece, right, because P stays the same, we can take that piece and leave it as is. That's the antecedent. That's the part that comes before the arrow. So that piece is going to stay the same. Now, when we negate our conditional, we have an and, right? So we've got P and Q and our antecedent and the negation of our consequent, this not Q here. And so now we've got to look at our statement and identify what's functioning like Q in this case. Well, that's going to be R. It's the piece that comes after the arrow. And so when we take the negation of our conditional, we'll use the antecedent as it is, P and Q, and the negation of the consequent. And so in this case, the negation of R. And so these two statements would be opposite of each other. They would be each other's negation. I think the tendency with something like this is to want to sort of apply negations to everything and even negate the P and Q here, but we don't need to do that in this case. A conditional's negation only negates the consequent and leaves alone the antecedent. It leaves alone the part before the arrow. It does negate the part after. And so I think that's an important thing to keep in mind. Now we could look at one more example where we have something like P implies the statement Q or R and aim to find its negation. And now this one is just a little bit different because here the antecedent is a single statement, but the consequent is a compound statement. And so we've got to keep that or take that into account when we do the negation here. Now, just as we said last time, when we negate a conditional statement like this, the antecedent, or in this case P, remains the same. We change it to an and then the consequent, which is in this case the compound statement Q or R, is what we need to negate, Q or R. And so we can write it this way, P and the negation of the compound Q or R. Now, if you're familiar with De Morgan's laws, and maybe I'll do another video on these as well, but if you're familiar with De Morgan's laws, you know that there is another way that we could write this as well, because we know that if we take the negation of an or statement, we would have an and statement, not Q and not R. And so we can simplify this, if you will, to express that here as well. And so that would be P and not Q and not R. I hope that helps clarify taking negations of conditional statements. If you have any other questions, feel free to put them in the comments below. Thank you for watching and have a great rest of your day.